So that part's tricky. I didn't get it right, but
115.
It's 116, isn't it?
Yeah. Negative 42. 318.
What's that one? Minus 42 or?
318.
Yeah, 318, isn't it? All right, so now I'm about to show you how to get the components. Now I'm going to show you how to get the components using your calculator, okay? But to do this, we're using degrees. There is also another way to measure angle, and that is radians. With degrees, it's 360 degrees around a circle. With radians, it's 2 pi. It's like 6.28 something radians, okay? The real, can we cap our pens? Put the caps on our pens. Let's not, yeah, don't write, no, don't write stuff with our whiteboard pens. Can we stop that? So, can we stop? Thanks. Let's not do that. Okay, so in your calculator, there's 2 different ways. We're going to use degrees. When you get to math class, they might make you use radians. Here's how you switch back and forth, okay? You go to your calculator, and you turn it on, and you go mode. And when you click on mode, you'll see there's radians and there's degrees. You want to go down, down, over degrees. If degrees are not highlighted, hitting enter will highlight it and make it be in degrees. Radians are the real measure of angle, so when you actually do trig, you're going to do radians. You want to be in degrees because it's much easier to picture a 45-degree angle than a 1.7 or whatever it is, you know, radian. I can't figure it out. So again, go mode, take your calculator, go mode, and then go down until the little cursor is over degrees and hit enter. Yeah? There we go. Does everybody have a calculator in front of them? This class will not be meaningful to you unless you have a calculator.
Thank you.
Do you guys have calculators you can bring?
I do. Yeah.
Buy new batteries. I can't say for sure the calculators I just handed out are in. Okay, so now here is the real test. If you take your calculator and you go the sine, if you find the sine of 90, the sine of 90, when you do it, should be 1. And what it's telling you is that on the unit circle, if we had a circle, right, like this, the y-coordinate would be 1. That was a very bad circle, but anyway, there it is, right? Okay. If you get some random number, then you're actually still in radians, so give it another shot, okay? Is everybody in degrees? Because it's really bad. You think you're like insane if you're in radians, because you're going to get just sort of random numbers, okay? Okay, so now this is the trick. Let's just hit the right arrow here. This is step by step, and for some reason it's like showing you step 2. Okay, but let me just show you. We'll write these down step by step. It's not really very hard, but the first step is that you find the trig angle. So in this case, we've got 12 meters. Right. This angle here is what is that? 27 degrees. Right. This is 12 meters. And so the first step is find the trig angle. Right? So in this thing, I just do what I always do to find the trig angle. This is 0.90. It's short of 180, so it must be 153. There we go, right? It's important, and if you mess this up, everything's going to be messed up, right? So this is find the trig angle, yeah. Right? Ta-da. So we got the trig angle. The next thing, and this is remarkably simple, have you ever wondered what the sine and cosine buttons are on your calculator?
Nope.
They are to find the coordinates on the unit circle. If you multiply those by the length of the vector, you get the coordinates on the 12-meter circle. It's not the unit circle, but the 12-meter circle. Okay, so, for example, let me just show you this. If I just go 12 cos 153, that's in the x direction, and then I go 12 sine 153, that's going to be in the y direction. Well, I'm going to show you. Okay? So you just type it into your calculator, and when I go 12 cos 153, I get negative 10.69. Right? And that is, what is this, meters? And then this is in the x direction. And when I do this, when I go 12 sine 153, it gives me 5.448. This is my answer. I'm done. Isn't that beautiful?
Wait, that's it?
That's it. I'm all done. Okay? Yeah, go for it. So I typed it literally with my calculator in degrees. I typed this expression. I did this. I didn't do plus. I just did this and then enter, and then did that and did enter. Okay? It's the magnitude, right? So the general form of this is this. It's magnitude cos theta in the x direction, and then you say it's plus, and then it's magnitude sine theta in the y. Cosine, I know it's exciting, but listen still. Cosine gives you the x component, sine gives you the y. But you have to have the trig angle correct. Otherwise it's going to just give you random stuff. Yes?
So that is what we just did right now.
Yeah, exactly. Yeah. That's it. Yeah. Yeah. So the question is this about the notation. Point your eyes up here, everybody. Okay. So this hypotenuse was in meters. Do you notice that? Right? So these components have the same units as the hypotenuse. Does that make sense? And then notice that I write it, and it's like x, and it's got a little hat on there. If you're in the back of the room, I'll enlarge that for you. Right? Got a little hat on there, right? That's how you say the x component. Y with the hat is how you say the y component. Notice that I say plus on there. Okay? Don't, this is the wrong day, so, yeah. Okay? So, don't go adding 10.69 to 5.448 because you can't do that. Remember, these guys are vectors, but what they really mean is that we are 10.69 over and 5.448 up, right? That's what it means. Okay? So when we add them, we're really, that little plus there means add them like vectors. Okay, yeah. 112 sine. Yeah? That is a 12 up there, isn't it? It is. Now, before we move on, okay, you've got the answer, you look at the answer. What you have to do is look at the way you draw the vector. Try to draw the vector to scale. So if somebody gives you a 27-degree angle, make sure that that angle looks, and I didn't do a great job of that, make sure it looks, a better job would be like this. Make sure it looks like it's well under 45 degrees. That's a little better. Okay? Hold on. Okay, so draw the thing like that. Look at that. Do you see that this side should be shorter than that side? Do you see that in this triangle? Guys, can we stop? Pay attention to me. Look at me. Okay, so this side should be shorter than this side, yes? Is it shorter? Is this number bigger than that number?
Seems to be that way.
Yeah, it is that way. So that's good news, right? Okay, here's the second thing. Notice that this vector goes up and to the left. Are our components up? Is this a positive component?